India, as per new education policy, government of India, even society is expecting quality entrepreneurs rather than the quality student from the campus. So this objective is already, because we have established a technology center in the 2014 itself and incubated more than 10 startups, and we got space more than 3,000, 4,000 square feet area in the technology center itself. So the first objective is fulfilled. The second, in connection with the linkage of our faculty and students to the global across. As far as the linkages of the students, are concerned, that I can define the knowledge in two ways: theoretical knowledge and practical knowledge. Theoretical knowledge can be imparted in the classroom itself by the well-experienced faculty, because SRKR Engineering College got really well-experienced faculty. So we got no problem for imparting quality knowledge. But at the same time, nowadays, we need the practical knowledge, practical aspects of the knowledge, nothing but an applied knowledge. For that, linkages with the industrial people, linkages with the industries, linkages with the retired professors of IITs, linkages with the working professors of IITs across the state, across the nation, even across the international, particularly across the European Union. They are running after Indian organizations for having a tie-up with Indian organization. So these linkages are very much mandatory for giving connection to our faculty, for linking our faculty and students to these higher ups of the industries, because nowadays under these online technologies, very easiest way to connect all of our faculty and students to the industrial people across the state, across the nation, across the international, we can connect our students. So as far as from SRKR Engineering College side is concerned, no doubt the government of India itself is pumping money for conducting FDPs, for rising up of the quality of knowledge, knowledge for faculty as well as for students. This is what already we are doing it. Almost more than 20 FDPs we have conducted this year itself. Congratulations to the, particularly for head Department of Computer Science, Chandrasekhar Garu, and coordinators Sirisha, Jagan Mohan, and Srinivas for conducting and for linking our faculty, our students, for raising up of the knowledge levels of the SRKR Engineering College. So thanks to all the coordinators, and thank you so much for giving me this opportunity. Thank you so much.
Thank you, sir. Now I request Dr. M. Jagapatiraj Garu, Principal of SRKR Engineering College, to deliver the welcome address.
Thank you, Shirisha. Is my voice audible?
Yes, sir.
Yes, sir. Yes, sir.
Okay, thank you. Once again, thank you. So, Dr. Nj Rajaram Garu, CEO, Apparel and Textile Parks, Government of Telangana, Hyderabad. Our CEO Nishant Verma Garu, our Director K. Vidyasagar Garu, Indian Foreign Services, former Ambassador for Kuwait country. Head of the Dr. Parkaraj Garu, Dean R&D, Head of the Department of CSC, and also the Head of the Departments of various departments, Deans, Coordinators, Faculty members of SRKR Engineering College, and also from the entire nation, and also the participants. Good afternoon to one and all. So today, first let me congratulate CSC department for conducting this one-week national level online FDP on data science and its applications. Definitely data science and applications, it is having a lot of importance nowadays. The reason for that is even the government or the entire globe, they are giving highest importance to emerging technologies. So definitely this data science will be useful in machine learning, whatever it may be, in all emerging technologies, that will be very useful. And hence on this occasion, I request all the participants to utilize this greatest facility, because eminent personalities, they are giving lectures. So on this occasion, I request the participants to utilize not only in CSR, right, in other departments also, for them also it will be useful. So keeping that in view, I request the participants to utilize this facility. On this occasion, it is my responsibility to say a few words about our SRKR Engineering College. And our college was established in the year 1980 with a vision of Sagi Ramakrishna Garu to make this institution as world-class institution. Eminent personalities of Bhimavaram and its surroundings area that took part in this vision, and today our college is having global reputation. We started our journey with 3 UG programs. At present, we are having 8 UG programs, 6 PG programs, and 7 PhD programs. And next year, we are expecting 2 more UG programs. So totally, UG programs may be 10 UG programs. At present, we are having approximately more than 400 faculty members and 300 non-teaching staff members and more than 6,700 students. And the college has a cluster of beautiful and spacious buildings with a state-of-art infrastructure in all the departments. Our college is accredited by NAAC with a CGPA of 3.60 on 4 scale. So it is the highest scale actually, as all of us know. All undergraduate programs are accredited 4 times by National Board of Accreditation, NBA. Our college is recognized as scientific and industrial research organization by Ministry of Science and Technology. Departments of Civil, CSC, ECE, EEE, IT, Mechanical and Mathematics are recognized as research centers by JNTU Kakinada. In ARIA 2020 ranking, our college secured the rank of Band A between 6th to 25th. And in AICT Smart India Hackathon 2020, our college team got selected for the first prize in the Ministry of Textiles problem statement and won 1 lakh rupees prize money. So in the entire nation, our students got first prize in Smart India Hackathon. SRKR Engineering College is one among 78 institutions in India who received perennial award of 1.75 lakhs under Unnata Bharata Abhiyan program by MHRD, Government of India, adopted 5 villages under this program. So we are having 14 excellency centers, and in all these excellency centers, continuous work will be going on. And these centers are mainly on water and all these things. So if the government need any suggestions or whatever it may be, they will approach these excellency centers, and we are giving guidance to our students also by using that. At present, the institution holds 3.86 crores of ongoing projects sanctioned by DBT, DST, SERB, AICTE, etc., etc. Consultancy is another feature in the cap of our institution. The college is providing consultancy to ONGC, Reliance, NRSA, IDEA, AP, Transco, Indian Railways, AP, state government organizations like Panchayati Raj, Irrigation, and central government organizations also. We are having 80 MOUs with industries, institutions, foreign universities for students and staff training programs, internships, collaborative research programs, student and staff exchange program, higher education, etc. So SRKR established High Hub, Innovation, Incubation Industry, the first of its kind in Andhra Pradesh. As of now, 19 startups are existing in our campus. The institution also established Business Incubation Center sanctioned by Ministry of Micro, Small and Medium MSME, Government of India. We are having 12 collaborations with the AP State Skill Development Program. In AICT Smart SRKR, IIC Cell secured Best Star Performing Rating 4.5 out of 5 by Innovation Cell, Minister of Education, Government of India. Stanford University, USA, has a University Innovation Fellows program with our college, and 12 students selected by them and attended Silicon Meetup. SRKR AEC got first prize of rupees 75,000 at state level FinTech College Connect Startup Challenge 2018 conducted by Government of Andhra Pradesh at Visakhapatnam. So during this pandemic situation also, as our Dean pointed out, we have conducted a number of FDPs. So under that, under Margadarshan program, we organized 1 week FDP on outcome-based education for 10 Minty institutions from 29th March 2021 to 3rd April 2021. We have organized a webinar on National Educational Policy 2020 on 14th March 2021. Department of Mechanical Engineering organized AICTE-sponsored online FDP on strategic methods for product development 22-27 February 2021. Department of EC organized AICTE sponsored 3 online STTPs on innovative teaching and learning methods for inspiring students during October to December 2020. Department of Civil Engineering organized AICTE sponsored 4 online STPs on capacity building and training. Like that, we have conducted more than 21, and today we are conducting another FDP under this CSE department. Now, even our NSS unit in our college is also very active. They have conducted so many events like Fit India, Cyclothon, Blood Donation Camp, World Water Day, World Note Avocado, International Yoga Day, like that we have conducted so many programs under our NSS program. Recently, we also conducted awareness programs to the faculty and students by the eminent doctors across the globe. Dr. Ganapati Raju from Chicago, he has given excellent awareness program to our faculty as well as students. And also in the month of February itself, last year 20 February month itself, we have given awareness on this coronavirus by Dr. Sandeep Varmagaru from Bhimavaram. So on this occasion, finally, I will conclude by saying a few words. Apart from our regular activities, our college focuses on research and development activities, collaborative research projects, consultancy works, high-hub center activities, product developments, in-house startups, skill development programs, technology training programs, certification courses, summer training programs, career guidance and counseling activities, personality development programs, art of living activities, Unnata Bharat Abhiyan activities for the rural development, etc., etc. By setting a pragmatic teaching learning environment where education is an instrument for social, economic, and cultural change, the institution tunes all aspects of the students for better career and future. So on this occasion, once again, I congratulate the CSE department for conducting this FDP, and also I advise the participants to utilize this greatest facility to enhance your skills in emerging technologies. And I thank the management. We are proudly, I can say proudly that our management, whenever we approach them, definitely they will accept. And I thank the management for giving me this excellent opportunity for us to conduct this meeting. So thank you very much for giving me this opportunity.
Thank you, sir, for your good wishes. Now I'd like to invite Sri K. Jevasagar Garu, Director of SRKR Engineering College, to share his views.
Thank you, Sirisha. Sirisha, can you hear me, please?
Yes, sir.
Yeah, okay. Good afternoon, everybody, and very happy to join this 1 week's FDP. Particularly, a special welcome to our chief guest, Mr. Rajaram. Thank you, sir, for taking time to join us today. And also all the faculty members from outside of SRKR across the country who are joining us today. Very welcome to you. I extend a very, very warm welcome to you from SRKR. We are delighted to have you with us this afternoon. And of course, my own colleagues, HODs, CSA department, and other dignitaries from our own college. Nice to have you this afternoon, and good afternoon to all of you. I am not neither a scientist nor a data scientist, an engineer by profession. I'm a diplomat. And my academic background also, of course, though I studied sciences, a bit of, not close to engineering. But I when I got the brochure and I was going through it about data science, a few key words have drawn my attention. I would list them out, which I noted down. Volumes of data, referring to the just information explosion these days, and patterns, deriving meaningful information, application, business decisions, and predictive models. And I saw these words, though they are purely referred to and mentioned in the context of data science and engineering, of course, but I can relate them broadly to other disciplines. For instance, even to the discipline that I come from, diplomacy. Or all of us, almost all of us, in our high school or college level, we studied our literature and English. We at least we used to have a compulsory question on precise writing. They used to give us a long paragraph or long, one more page or 2 pages of text, prose, and would ask us to summarize it in less than, say, 100 words or something like that, which we used to call precise writing. So this data science, when I saw it broadly, my understanding is this is really relevant in any walk of life, in any discipline, because these days information is so much that you should be able to analyze volumes of data and summarize them and crystallize them into patterns, and through that you make predictive models and be able to apply the essence of it to other disciplines or to relevant to society or development, the economic development. For instance, when you see you would never expect in engineering subjects, a terminology, something like business decisions. So in other words, this is very relevant. When I said I also can relate it to diplomacy, I'll tell you what I meant by that. For instance, at higher level, at senior levels, say, for example, there is a major visit by the Prime Minister of the country or the President of the country or a foreign minister of the country visiting another country. They don't go through the files and volumes of information, but they just take a briefing from the ambassador, trying to understand what is the broad picture or status of relationship between the two countries, and where does that country stand in terms of India's critical issues, say, for instance, border issues or human rights issues or climate change. So in other words, we call it broad picture. At high level, you want to understand what the broad picture is. You have no time to go through volumes and volumes of data. In other words, when the way I understood data science is, it is a tool or it is a discipline which produces instruments or applications or which could analyze huge amounts of data and produce essence of it, the themes of it, which are applicable in day-to-day life or for the development, or say, for instance, we talk about weather predictions. Maybe this data science is applicable there also. I'm not familiar, but something similar. The other point, which is very relevant when we talk about FDP, is the new national education policy, NEP, emphasizes so much on multidisciplinary and interdisciplinary studies. And the very fact that this data science faculty development program, the organizers have invited HODs and faculty members from across the spectrum, from various disciplines, that itself shows how interdisciplinary the knowledge has become these days. Unless you know at least a bit of other disciplines, you can't do justice to your own specialization. So this is very relevant. And also the faculty development program, if I remember, this is the third or fourth in just a few months that SRKR has organized, and I myself have participated, which shows the frequency of these FDBs underlines how important it is to train our own faculty so that they can keep pace with the technology explosion. If you remember, 3-4 centuries ago, even though we had major scientific innovations, but these innovations used to come every 20 or 30 major innovations. The frequency was very low. It was, major innovations came not in quick succession. But today, the data that we produce, the information that we produce, the innovations that we do, or the discoveries we make, their shelf life is so short that you have to really keep pace with them. Unless faculty members keep pace with these innovations, they would not in turn be able to guide or generate that creativity among their students. So this FDP, I would request all the participants, and I would think that most of you are faculty members, please take this very seriously, because it does immense good to your own confidence, your own ability to communicate to your students, and keep pace with the explosion of technology and knowledge. So these FDPs in that sense are very relevant, and NEP, by emphasizing this, or AICTE or UGC, they are emphasizing on these FDPs so much for this particular reason. And I would request all of you, and I would encourage all of you to take advantage of that. And I congratulate the organizers for organizing this event today. And once again, welcome to all of you, and thank you very much.
Thank you, sir. So we have today with us the invited speaker of today's session, Mr. Krishna Naik, sir. Welcome, sir.
Thank you, ma'am.
Now I would like to invite the CEO of SRKR Engineering College, Sri SRK Nishant Varngaru, to address the participants.
Good afternoon to all of you. I welcome you all to this 1-week virtual FDP on data science and its applications. Firstly, I would like to thank Dr. Nj Rajaram Garu for dedicating his time for this FDP. Thank you, sir. So I wish all the participants to make good use of this FDP to upgrade their skills and knowledge. I wish this FDP to be a grand success. Finally, I thank the coordinators, Dr. GNVG Sirisha Garu, LV Srinivas Garu, Dr. RNV Jagan Mohan Garu. So I also thank our principal, Dr. M. Jagapatraj Garu, our director, K. Jeevasagar Garu. Thank you.
Thank you, sir, for your best wishes. Now I would like to invite Mrs. K. Arunakumari, Assistant Professor of Department of Computer Science and Engineering, to introduce the chief guest.
Thank you, Sirisha. Good afternoon, everyone. Myself, Arunakumari, working as Assistant Professor in the Department of Computer Science and Engineering, SRKR Engineering College, wish you all a warm welcome. It's my tremendous honor to introduce today's chief guest, Dr. Nj Rajaram, who is presently working with the Government of Telangana as the Chief Executive Officer of the Textile and Apparel Parks. Prior to this, Dr. Rajaram served as the Director of National Institute of Fashion Technology, Hyderabad for 5 years. Dr. Nj Rajaram has done his BTech in Mechanical Engineering with distinction from JNTU Hyderabad in 1984. He has completed his MTech in Computer Science from Usmania University in the year 1987 and Masters in Statistical Quality Control and Operations Research from Indian Statistical Institute, Kolkata. In 1998, he received his doctorate in Computer Science from IIT Bombay and was awarded the Best Thesis Prize for his research in the area of software quality and reliability. He has a Master's in International Business from IIFT New Delhi and an MBA in Technology Management from Anna University, Chennai. He has over 33 years of work experience in new product design, information technology in design, quality, operations, process and product research, quantitative techniques, and data analytics. He has worked both in academics, teaching and research, and business in various capacities. He started his career with the National Informatics Center at Chennai. He successfully completed several automation projects for various government departments in the states of Tamil Nadu and Maharashtra. He headed the systems automation for Department of Atomic Energy while on deputation with DAE. He subsequently joined NITIE Bombay as professor and taught postgraduate level courses in the Department of Information Technology. After his stint with NITIE, he joined the corporate sector and worked with leading IT outsourcing companies like Aptech Software Limited, where he served as the CTO, Sintel Incorporation as the Chief of Quality, Intelligroup Incorporation as the Vice President and Head Global Quality, Tanla Solutions as the President and COO, and Infotech Enterprises as the Senior Vice President in Business Excellence. He has taught courses in NMIMS Hyderabad, Mahindra University Hyderabad, University of Hyderabad, and IIT Gwalior. His current research interests are in the areas of application of business analytics, machine learning, deep neural networks, business process improvements, operations research, software quality and reliability, and operations management. He has keen interest in teaching, research, and academics. He has several publications to his credit and has been an invited speaker in several forums. He has received numerous awards for pioneering research in the field of software quality. He was selected as one of the top CTOs in India by Network Computing. He is also a sports enthusiast and stresses on physical fitness through participation in sports. I thank the organizing committee of this faculty development program on data science and its applications for giving me this wonderful opportunity. Thank you once again. I hand over the session to Sirisha.
Thank you, madam. Now I feel sincerely obliged to invite Dr. Nj Rajaram Garu, CEO, Apparel and Textile Parks, Government of Telangana, to share a few words about the FDP. Welcome you, sir.
Very good afternoon to all of you. Well, a lot of you spoke about several things about the institution as well as the development of the institution and the growth of the institution. Are you able to hear me, please? Somebody could respond?
Yes, sir. Yes, sir. Yes, sir.
Thank you. Thank you. The college, SRKR Engineering College, is not very new to me, primarily because I have visited this college a couple of years back when I addressed a similar FDP for the students in the area of machine learning. The other day, when our Professor Jagan asked me to take a session, I said I readily agreed because I love teaching, even though I'm in an administrative role with the government. Since I do research in the area of artificial intelligence, neural networks, deep learning, so on and so forth, I gladly agreed to share my viewpoints as well as the subject with the audience. I should really thank the institute for calling me for the second time. Primarily, I know Mr. Jagavati Rajagaru because last time I had met him. Professor Ranga Garu, Jeevasagar Garu, Ramakrishna Garu, Chandrasekhar Garu, and Jagendra Garu, and Parka Raju Garu. Thank you so much. And also the organizer or the coordinator who is conducting this program and managing this program, Dr. Jagan Garu. Very importantly, I thought I just offer a couple of things in this particular talk because I don't want to take much of your time now. I got a session on day after tomorrow where I'll be talking in detail about deep learning and neural networks. And that's my area of interest. Well, when you look at decision sciences, data sciences, it's primarily generating knowledge for action. I could see about 180 odd participants in this seminar. Possibly many of them are from computer science. And I also expect people from the other divisions, other departments like mechanical engineering, electrical engineering, civil engineering to also attend such programs. Primarily because this area of data science or machine learning or artificial intelligence or deep learning or neural networks has to be applied in other areas. When we see published models or architectures in the public domain, I see them limited to certain areas, okay, like images, like identifying characters, so on and so forth, or at the worst, in a practical application, facial recognition. But these have got, this particular area of machine learning and neural networks have got excellent applications in other domains as well. For example, now there is pandemic. You can find out the intensity of pandemic in a particular location or geography. Or possibly you can look at how the government is acting upon the sufferers or the people who have been contracted with this disease, and what sort of processes they are undertaking. So these are the areas one could adopt. And you can also check. Today morning I was reading an article from Indian Institute of Science. They have developed an algorithm to identify whether the waters or the sewerage water is infected with COVID. So I'd expect the audience to be amongst the other disciplines as well. Well, when you talk about machine learning, it's primarily a set of algorithms you design. A computer scientist would design. A person working in data science or machine learning would design algorithms. And these algorithms are expected to generate some knowledge, and this knowledge has to be actionable. That's the end intent of the artificial intelligence or data science or machine learning or neural networks. Now, people ask me what sort of a background you require. The background you require here is an excellent knowledge on linear algebra, statistics, and computing and programming too. So a combination of these four areas would make a good data scientist, would make a good a machine learning modeler. What we are looking at is not just coding. Coding, you can use Python, or you can use TensorFlow, or you can use a framework like Keras, and you can develop programs. But the point here is how meticulously you use these models and how you adapt these things to the other domains, which I was talking some time back. Now, so all these days, people were relying on a subject called data mining. When you looked at data mining, when you could explore or identify certain novel insights from a collection of data. Now, these novel insights is not expected to end there. As I was telling you, a computer science or a computer scientist ends there. But the application of this is very essential. That's why we get into machine learning. Of course, machine learning pervades into multiple areas like deep learning or deep neural networks. We have convolutional neural networks, recurrent neural networks, so on and so forth. Of course, we have other models as well. Possibly on day after tomorrow, I will deal with this in detail and how you model these and how you generate architectures of this. Very fundamental thing you could have seen for a commoner or a layman the application of artificial intelligence or machine learning. You could have seen the program correcting on its own, for example, a spell check, and you could also see in word processing tools which would offer words before you type them. Some of you would have been surprised. And you would have seen application like Siri, which you pose questions and you would answer. Possibly it's working on a database and it has generated algorithms for which there are pre-prepared answers. Of course, you have various lectures on types of machine learning, so on and so forth. I would not talk about right now. Possibly other speakers would also get into this topic. Next, very important is, I want to stress this along with other points. Learning. As a human being learns, he learns out of prior experience, and he generates further experience. And he deploys this experience for further learning, possibly on the same set of data, or it could be on a different set of data or a new data, to experiment how far his learnings has generated results and further improved the experience. In other words, when you repeatedly learn something, you repeatedly improve on the experience and your performance is expected to improve. In other words, when you look at data science, this is the same philosophy adopted. So when I try to learn, I generate experience, I deploy this experience, and post-deployment, when I measure the performance, it has to show an improved performance. That's what the end objective is. That's why all the areas of artificial intelligence, machine learning, data science, neural networks, so on and so forth, talk about collection of data. It talks about abstraction of this data into a model. For example, you see a gravitational force. A gravitational force is generally, now we call it as a value G. Okay, it is given as rate of change of velocity divided by time. So what we do is, when we observe this rate of change of velocity or acceleration, in other words, for a mechanical engineer or a student from physics, this has been observed to be constant, and that's why they derived a model. And this model is applied everywhere, whether you throw a cricket ball, or whether you throw a football, or whether you throw a stone, the same acceleration due to gravity is applied. So you abstract this model from the data. Then what you do is you try to generalize that. How do you generalize? You try to see that whether it is going to be applied in a new set of data, right? So this is what it's about. Data science is about. And finally, you try to evaluate whether the results which you have produced are correct or not. So the entire gamut of activities in data science is going to be collection of data, whether it's going to be through a device, or whether it's going to be through your memory, and primarily recall this data and apply some models to generalize that, generalized into an abstract form. And after you generate an abstract form, you try to apply into new set of data and find out whether it is really applicable at all or not. Now, so this is the entire gamut of activities where we apply these algorithms to generate models. And I wish, and I expect the computer scientists to not just stop at that point. They need to involve in interdisciplinary activities or research, so that this is going to be applied in other areas as well. For example, I'm a mechanical engineer turned computer scientist, but I'm working on areas wherein through image processing, I'll be able to identify whether the products are spurious or whether they are original. Okay, so these are some of the areas I work. So in the similar way, people working in, say, reliability engineering, or somebody working in the area of chemical engineering or drug modeling, I expect them to adopt these techniques in those areas as well. So I wouldn't like to continue much because, the program started at 1:30. Possibly many of you would not have had lunch. I would stop at this point, but not forgetting one important thing. There is one little girl, Manasa, who sang the prayer song. She sung it very, very nicely. Normally, the people who, during the inauguration process, the person who, sings such songs are forgotten, and people dwell into subject matters, and those people are not given credits. I'm sure this little girl or a student, I expect that she has been learning Carnatic music and she has performed exceedingly well. I was really appreciating that the prayer song which she offered during the inauguration program. With this, I stop. I don't want to further talk about this. We meet on day after tomorrow when I deliver my talk for 3 hours. Then we can discuss in detail about various models, and I would be primarily discussing on neural networks and deep neural networks. Thank you so much. Thank you once again for the Institute for inviting me for the second time. First time it was physical, second time it was, through an online mechanism. Thank you so much. Thank you. And I also expect the participants would benefit very much. They understand what the teachers teach you. They are able to distinguish between various models, and finally implement what they learn here in their fields of studies. Thank you so much. Thank you once again to one and all.
Thank you, sir. Thank you for explaining the various applications of this data science, importance of this data science field as an interdisciplinary field. Thank you, sir. Now it's time to felicitate our guests. I request the CEO of SRKR Engineering College, Sri SRK Nishant Varma Garu, to felicitate the chief guest, Dr. Nj Rajaram Garu, with an e-memento.
Sir, in this virtual mode, we are honoring you with an e-memento. It is not possible to view physically. Try to accept these, sir. We'll send it to your mail, sir.
Thank you so much. Thank you.
Now I request our principal, Dr. M. Jagpatiraj Garu, to felicitate the secretary and correspondent of SRKR Engineering College, Sri S. Vittal Rangaraj Garu, with e-memento. Now I request our principal, Dr. M. Jagpatiraj Garu, to felicitate CEO of our college, Sri SRK Nishant Varma Garu, with e-memento.
Thank you, Ms. Sirisha. Thank you.
Now I request our principal, Dr. M. Jagpatiraj Garu, to felicitate Director Sri K. Jeevasagar Garu, with e-memento. Now I request Dr. V. Chandrasekhar Garu to felicitate our principal, Jagpatiraj Garu, with e-memento. I request convener of this FDP, Dr. V. Chandrasekhar Garu, to felicitate Dr. P. Ramakrishnan Raju, Dean R&D of SRKR Engineering College, with e-memento. Thank you, sir. Now I invite Mr. N.V. Srinivas, coordinator of this FDP, to deliver the vote of thanks.
Thank you, madam. Is my voice is clear, madam?
Yes, sir.
Good afternoon, Andhra. Myself, N.V. Srinivas, coordinator of this FDP, and working as assistant professor in the Department of CSE. It is a great honor and privilege to propose the vote of thanks on this memorable occasion. On behalf of the Department of CSE, SRKR Engineering College, and the organizing committee of 1 week national level online faculty development program on data science and its applications, I thank the management and the principal of SRKR Engineering College for giving us the opportunity to conduct this national level FDP and for providing financial assistance for conducting this FDP. I thank today's chief guest, Dr. Nj Rajaram garu, CEO, Apparel and Textile Park, Government of Telangana, for accepting our invitation and for sharing his inspirational thoughts and his experience in the field of information and technology. I thank the CEO and governing body member of SRKR EC, Sri SRK Nishant Garu, who graced us with his presence. I thank our director, K. Jeevasagar Garu, for his gracious presence and his inspirational message. I thank our principal, Dr. M. Jagapatiraj Garu, for his valuable message and sharing his views. I thank Dean R&D, Dr. P. A. Ramakrishnan Raj Garu, for sharing his views. I want to express our heartfelt gratitude to all the guests, deans and heads of various departments and staff who joined this event today. We are fortunate and assisted by the head of the department, Dr. V. Chandrasekhar Garu, who have been a constant support and have given us a lot of encouragement. Thank you, sir. I extend our thanks to all our staff members for their enormous contribution in the organization of this FDP. I would also like to thank press and media for covering this event. I would also like to thank one and all who directly and indirectly supported us all these weeks for making this event to happen. Finally, I thank all the participants for their interest towards emerging area, data science and its applications, and hope this FDP will help them to reach great heights, and wish you have a wonderful time during the sessions to come. Thank you, one and all. Thank you, madam. Over to you.
Thank you, sir. Now this inaugural function is going to be closed with the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
We shall soon begin our day 1 session. I request all the interested guests to continue with the session 1. Topic of today's session is data science and its applications, and we have with us Mr. Krish Naik, who is a data scientist and YouTuber with 3.75 lakh subscribers. So before we begin today's session, I would like to announce a few guidelines to the participants. All the participants have to submit the feedback form at the end of every session, which will be provided to you through the chat window. Please enter correct details in the feedback form because they will be printed in your certificate. Attendance in all the sessions is compulsory for certification. And please mute your mic and also video. Switch off your video while the speaker is presenting. Use hand raise feature if you have any doubt, and unmute only if your name is called for. And to know who have actively participated, on the final day, we are going to conduct an assessment test. And all the participants who have scored at least 50% or more in the final assessment test will be awarded FDP completion certificate. Now I invite Mrs. DNSB Kavita, Assistant Professor in the Department of Computer Science and Engineering, to introduce the speaker of today's session, Mr. Krish Naik.
Thank you, Madam. Good afternoon, everyone. I am Kavita, Assistant Professor in the Department of CSE. Today, it's my pleasure to introduce today's resource person, Mr. Krish Naik, who is the Chief Innovation Officer and co-founder of iNeuron.ai. He was graduated from PDA College of Engineering, Karnataka in 2007. He was a proven IT professional with experience of 9+ years in software development and project implementation. and currently working as lead data scientist in machine learning and deep learning developer. Possesses widespread and progressive experience in the IT industry, focusing on business analysis, design, development, implementation, and migration of large-scale, big-budget business transformation projects. Impeccable knowledge for initiating applications with algorithms, data structures, binary tree, artificial intelligence, machine learning, deep learning, convolutional neural network, recurrent neural network, and software development and project implementation. Actively contributes in conducting expert business systems analysis, identifying business improvements and information system solutions, coordinating and scheduling projects, developing and monitoring project plans, and managing the end-to-end delivery of projects. Coming to his experience, he worked as lead data scientist in Panasonic India, lead data scientist in EY, and as tech lead in Honeywell, senior associate in Publicis Sapient, software engineer in HCL Technologies. Finally, he is also very active in posting videos in YouTube with 3.75 lakh subscribers on topics related to machine learning, deep learning, AI, with many real-world problem scenarios. I would like to add that I am also a subscriber for Krish Nayak sir channel from the past 2 months. We welcome you, sir, and I hand over the session to you, sir.
Thank you, ma'am. I'll just share my screen so that we can start the session. Just give me a moment. I think, ma'am, you can stop sharing. Thank you. Okay, just let me know if you're able to see my screen, ma'am.
Yes, sir. You can see it.
Okay, perfect. So hello, guys. First of all, let me on my video also, or at least you'll be able to see me, and let me know once you're able to see me. So I hope everybody is able to see me, right?
Yes, sir.
Yes, sir.
Okay, perfect. Now, what I am going to do is that I'm just going to start this session and make sure that how the first of all, just I'll talk about the session, what we are going to cover, and how this session is going to go ahead. And at the end, I'll also be taking up some amazing projects, end-to-end projects, basically how we should go ahead in solving it. So let me do one thing. Okay. So guys, in this session, we'll try to understand more things about data science. We'll try to understand, how data scientists work, what are the various roles, and what should be the roadmap to learn data science, and what all topics are basically included in this specific field, what all you really need to be good at if you want to get into it. Before I start this session, I just want to give a brief introduction about myself, even ma'am has also given us. So I started my IT career from 2011. I passed out my college at 2011 from PDA College of Engineering. It's in Karnataka, North Karnataka, Gulbarga, the name is. And I got placed in HCL. I worked over there for 1.5 years. Then I moved into data science industry. So the opportunity was that initially I was a software engineer. So initially I did a .NET project, and that same project was a kind of AI project, so that actually led me to move towards data science because it was pretty much interesting. Then after that, I kept on working. I started with machine learning. Then I got to know about deep learning. And there were times, because during that time, not much materials were available in the internet. Everything that we used to do was learn from research papers, come up with solutions, how to actually implement something. But just going back 2 to 3 years back, it became pretty much popular and many people wanted to study. So that was the main reason why I actually created my own YouTube channel, where I could share all this kind of information in an easy way, so that whatever difficulties I have actually faced, you should also not be facing. So do definitely visit my YouTube channel called as Krish Nayak. You can actually check it in the YouTube channel itself. So let's continue and let's understand what all things we'll be discussing in this entire session. Here I have just written in short, complete roadmap towards data scientist in 2021. What all things we need to be very good at, what are the entire life cycle of a data science project, what are the various roles that we basically talk about, AI, machine learning, deep learning, all these things will be discussed. And after completing this, I'll also be showing you how you can design an end-to-end projects, so where I'll be talking about the steps that you should actually follow. And problem statement can be from any specific domain. The process of the entire life cycle of a data science project will be almost same. Okay, so let's proceed without wasting any time. So the first thing that we are going to discuss is what is the agenda in this, right? So in the agenda, we'll try to understand who is the data scientist, what are the life cycle of a data science project, and then work of a data scientist, and then we'll discuss about the roadmap. Now, before going ahead, always understand, if just consider this, the universe of, you really want to work in data science, just consider this yellow box as universe. Okay. And here, this universe is called as AI. Okay. AI basically means artificial intelligence. Now, what is AI? Here you are actually creating applications in such a way that it will be able to do all the functionalities by itself without any human intervention. This is how you can actually define an AI, an artificial intelligence application. Some of the examples you can see is Netflix, self-driving cars, and many more things, right? You have Amazon.in website, it is a kind of AI application. And over there, at the end of the day, like some of the functionalities I'll talk about, self-driving cars, it will actually help you to travel from place A to place B, where you don't have to drive. Netflix provides a lot of recommendations, of what movie to see. Similarly, Amazon.in provides a lot of recommendation, like what products you should basically buy, that kind of suggestion. Over there, human intervention is not required. How your history will be, how you are basically selecting the products, how you're basically seeing the movie, based on that it will be decided. So just a brief intro about AI. Now, if I come to the next step, which is a subset of AI, which you can actually see this particular circle, it is called as machine learning. Okay. Now, if I talk about machine learning, what exactly is machine learning? Machine learning is nothing but it provides you stats tools to analyze the data, to basically visualize the data, to do some kind of to help you to create some kind of models which will be able to solve some of the problems like classification, regression. It can be unsupervised machine learning techniques also. And there are a lot of things which will actually, and all those kind of stats too, is basically provided by this particular machine learning technique. Here you have some amazing libraries which will actually help you to do all these tasks. Now, coming to the next part, which is a subset of ML, which is called as deep learning. Now, deep learning is, again, as I said, it is a subset of a machine learning. But why deep learning came into existence? Just understand that scientists started thinking, can we make the machine learn like how we human being learn? So in order to make sure that an application can mimic a human brain, that is the reason why deep learning came into existence, right? And here you will be learning more about neural networks. Neural networks basically means you'll be seeing how a neural network is basically created, how you can actually do an image recognition through that particular neural network. All those kind of activities will be actually done with the help of deep learning techniques. Now the main question rises, where the data scientists come into picture? So you may be seeing various roles like AI engineer, ML engineer, DL vision developer, and all. And one specific role is data scientist. Tomorrow, if you are basically getting hired in a company, so company over there, if you have given a role of data scientist, tomorrow any kind of work that you get, let it be machine learning, let it be deep learning, as a data scientist, you should be able to accept it. So in short, a data scientist should be able to do all this kind of task. And again, always understand the final goal is actually to become what is the final goal? It is to create an AI application. That is what is basically required over here. The final goal is basically to create an AI application. This is the most important. And these are some of the basic examples between AI versus ML versus DL versus data science. Now coming to the next topic, what is the work of a data scientist? Now over here, let's consider that I want to solve a specific project for a data scientist. Any kind of project it can be air quality index, it can be different types of project, it can be whether a customer is going to leave the bank or not, it can be image recognition, it can be any kind of specific projects. Okay, so here what we are trying to find out, what is the work of data scientist. Okay, so here you have a data science project. Okay, the first step always is requirement gatherings. In this requirement gatherings, there will be multiple people involved. One is the business analyst, One is the domain expertise of product owner. Product owner is basically a person who will be owning this entire project. His work will be basically delivering to the company or to the client. Okay, so over here you'll be seeing that the domain expertise person and the business analyst will discuss within themselves and try to do all those kind of requirement gatherings, which is basically required for this kind of project. Okay, they'll try to plan up all the sprints, how many stories needs to come up, for implementing the entire project, how many different stories will be coming up. And they will also make sure that from the development side, how many employees they'll be requiring, and all those kind of activities will be done. Okay, after this, what we can actually, the next step that usually goes is that this, once the requirement gathering is jotted down, it will be sent to the data analyst or data scientist or the analytics team. And now this particular people will be doing the discussion with domain expertise or product owner to find out from where can we collect the data, because data is the most important thing in this kind of projects. So what they'll do, they'll have a discussion with the domain expertise or product owner along with the analytics team, and they'll try to find out from where that particular data can come. Now, data can be available in the internal database, right? So in the internal database also data will be available in the cloud or third-party APIs. In the cloud also data will be available, right? So, probably they really have to buy some amount of data from third-party vendors and all, right? So once they find out the sources of the data, then what they do is that they try to collect that particular data with the help of a big data engineering team. They will store it in some kind of database, right? So here your big data engineering team will come, right? Where probably along with the big data cloud team may also come, where they will decide like how they should basically store the data in the databases. It will be huge databases like Hadoop databases, MongoDB, different kind of databases can be basically used. Okay. Then after that starts the life cycle of a data science project. Okay. Now extensively the entire analytics team. Now how many roles we have actually seen over here? We have seen domain expertise, product owner, business analyst. We have actually seen data analyst, data scientist. We have seen the big data engineering team. We have also seen the cloud engineering team, right? Now, when we go to the life cycle of a data science project, here mostly the data science team will basically be involved. So first step, what is in the life cycle of a data science project? You have something called as feature engineering. Then you have something called as exploratory data analysis. Then you have handling missing values, handling outliers, category encoding, normalization, standardization. These are some of the techniques that we do in feature engineering. Why this particular step is very much important? Because understand that when the data that you will be collecting, it will not be that clean. The format may not be right. It may have some kind of missing values. It may have a lot of categories. Sometimes you'll not be able to even understand that particular data. So what you have to do is that for analyzing it, making it perfect, you have to actually follow this particular steps, where you'll be handling, you'll be cleaning, you'll be making sure that the data after all these steps will be a high quality data, which you'll actually give it to the model to do the further predictions, right? So very much important step. Now coming to the next step, which is called as feature selection. Now suppose in my data set, I have thousands and thousands of features. Now the next question rises, are all the 1,000 features required? And the answer is no. So in this particular step, what we do is that we'll only select those features that are important. And inside this, there are various techniques like correlation, forward elimination, backward elimination, univariate selection, random forest importance, feature selection with decision tree. So different techniques are actually there. And probably I cannot go more into this particular technical thing. If you really want to follow, I've already created all this kind of videos in my YouTube channel. Okay. Then you go to the next step. Once after this two particular step, you know what is the most important data. You have the clean data. Now you actually do the model creation and hyperparameter tuning. In the hyperparameter tuning, you have various steps like grid search CV, randomized search CV, Keras tuner, Bayesian optimization. These are some AutoML techniques like hyperop, genetics algorithms, optuna. So all this, some of them are actually AutoML techniques, which will actually hyperparameter tune your model itself. That basically means increasing the quality of the model. Okay. Now coming to the next step after this, now my model is ready. It is performing well. The accuracy is very good. Suppose now what we do is that we plan to deploy this particular model in the cloud. Now for the deployment also, we use some kind of process called as Dockerization, where we Dockerize this entire model. After Dockerizing it, what we do the model deployment, and then we do the deployment in different clouds platform like AWS, Azure, Heroku, GCP, I missed that particular Google Cloud platform, but that can also be used for doing the deployment purpose. Now, after the deployment is done, then on the new data, the prediction is done from the model. And again, all the accuracy is basically checked again and again. If the accuracy comes down, then again, we really need to do the model monitoring and retraining purpose. And when we do the retraining, it again has to go back to the feature engineering. Probably there will be adding more amount of data and all, and we'll continue the life cycle again and again. Okay, so this is the entire life cycle of a data science project. I will give after I complete this PPT, I'll give one example of a use case, like how we should basically define all these things, and it'll make more sense. Okay. Now, work of a data scientist. I've already shown you this particular diagram. Now let's understand the roadmap to the data to become a data scientist. So first is what all programming languages you need to focus on. Second is mathematics concept, which all mathematics concepts you should be very, very good at, because maths is huge, so obviously it is not possible that you have to be very, very good at from everything that you should know, but some of the very important topics where you'll be able to solve a lot of business use cases. Coming to the third part, that is statistics. Then you have databases, then you have machine learning, deep learning, natural language processing, and finally, which are the cloud platforms you should focus on. So let's go. As usual, without wasting any time, I don't want to waste and tell you that you have to learn multiple programming language. Instead, you can learn Python and R. Yes, there are different programming languages like C++, Java, but understand Python has many number of packages. If you are probably planning to go towards data science in core, probably do a lot of things in deep learning, I would suggest go with Python. Yes, there are researchers who also go with C++, because always understand whenever a new library is basically created, first an API version is basically created with the help of C++, and then same API is exposed to the Python programming language also. Now, coming for the maths for data scientists, what are the maths that are required? So I'll divide it into three main sections. One is calculus, linear algebra, and statistics. Okay, so calculus, linear algebra, and statistics. Calculus basically means what is derivative. Some of the other way integral will be used. How you have to derivative is just like finding the slopes, guys. Okay, so just understand in this particular way, these are some of the topics that will be required. In linear algebra, obviously, right, everything can be represented in vectors. If you want to perform any kind of operation like matrix calculation, a lot of distance from one point to a plane, this all kind of questions usually comes in this. Linear algebra is also a very, very important subject altogether. Okay. I think there's some disturbance. Okay, sorry. Okay, now coming to the next one, which is nothing but statistics. Statistics is also very much important in terms, because whenever you're dealing with this kind of projects, there is statistics involved, because this has huge amount of data, and any maths, any types of visualization you have to apply on that particular data, statistics will come into picture. Okay, now coming to the next one. What all statistics topics we really need to learn. This is very much important. I have divided this into two parts, that is basic statistics and advanced statistics. So here you can see basic statistics and advanced statistics. In basic statistics, what are all the topics that is basically involved? Here you can see probability. I've written, and for this I've created two playlists, okay, in my YouTube channel also. So if you go and check out my YouTube channel, there you'll be able to see these two playlists. So here you can see introduction to basic terms, variables, random variables, population, sample population, mean, population distribution, sample distribution, mean, median, mode, range, measure of dispersion, variance, standard deviation, Gaussian normal distribution. All these topics have already been explained in this particular playlist itself. Then you have QQ plots, Chevinev's inequality, discrete and continuous binary distribution, and log normal distribution, power law distribution, box cost transform, Poisson distribution, application of non-Gaussian distribution. So these are some of the topics which you really need to know. After learning all these particular topics, what will happen is that you will be very much comfortable with all data related things, like how we can visualize, analyze, explore the data, right? By using all these particular things, you'll be able to learn some information about the specific data. And again, you can check out my playlist where I've actually included all these particular topics. Now, coming to the next step, what are the databases that are required? Now, always remember, whenever you are going into data science, two different types of databases is required. One is SQL database, one is NoSQL database. Here I've used named different types of databases, but understand in this particular database, it can be either SQL or non-SQL, okay, or NoSQL. So you have Cassandra, MongoDB, SQL Server. This is from Microsoft. MongoDB is also there. Amazon S3. So this is nothing but a storage unit that is provided with the Amazon Cloud Service. Then you have Google Bigtable, you have Hadoop, you have Elasticsearch, MySQL, Hive. These are techniques that are basically used in big data and to store the data efficiently. And here you use different kind of databases. Even in industries, they use either one of this particular database in short to do most of their work. Okay. Now coming to this machine learning roadmap. Now we have understood about the databases also. So, okay, in machine learning roadmap, I would like to talk about three important things. One is supervised machine learning, unsupervised machine learning, and reinforcement learning. So in supervised machine learning, what we do is that we basically say that whichever data has labeled data, we have different algorithms to solve that particular problem statement. In supervised, we usually have two different, if I talk about in supervised, it is basically having three different types. Okay. One is, as I said, supervised, right? Unsupervised. And the last one is basically reinforcement. Okay. And usually in supervised, we usually solve two types of problem. One is classification, and the other one is something called as regression. So this two problem statement we basically solve. In unsupervised machine learning, we use clustering technique. And in reinforcement, we have a lot of reinforcement techniques where we can train a bot, we can train a game, something like that. Okay. Now, if I talk about one very important thing in supervised, what are the different types of algorithms? You have like linear regression, right? You have logistic regression, you have decision trees, you have random forest, you have
Sir, good afternoon,
XGBoost.
everyone.
Sorry. Is there a problem? Sorry. Okay. So you have all these kind of algorithms. In clustering, you have k-means algorithm, you have hierarchical mean, you have DB scan. So different algorithms are basically used in this kind of things also. So all these kind of algorithms I have already created in my playlist where you can actually check out. But again, understand what is the main aim over here is to basically predict, predict. Probably I can take one example. I want to find out the price of the house in Bangalore. Okay. So this may be a problem statement. For this, I may have a specific data. This is a kind of supervised problem statement. And we know that the price is usually a continuous value. So this becomes a regression problem statement. So if you go and check out my ML playlist in my channel, this entire roadmap is basically been mentioned with all the explanation over there. Now coming to the next one, which is nothing but the complete roadmap to prepare for deep learning. These are all the things that you should basically learn with respect to deep learning. One is introduction to neural network, loss function, optimizers, gradient descent, stochastic gradient descent, ADA-grad, RMS prop, ADAM optimizers and all. So you will be starting from left to right. In the left, it is very much simple. Artificial neural networks you start with, then you probably make multiple projects with the help of ANN. Then after this, what you have is that if you really want to understand about this, you have something like convolution neural network, you have transfer learning techniques, you have object detection, RCNN, you have deployment projects. And then when you go to the right hand side, you basically have RNN, LSTM, GRU, word embeddings. All these particular techniques are there. And right now, the most advanced one, which are there, is basically transformers, BERT, Hugging Face, and K-train. Okay, now these all things are actually there. And when I talk about transformers, Hugging Face, and all, this really works well with NLP data set, so natural language processing, which is basically required in order to do various tasks that is related to text data. Here you use this particular techniques. In machine learning also, you have various techniques. And if I talk about these topics like word embeddings, word to vec, right, these are techniques which will actually convert your word your text data into some vectors, because understand model will not be able to understand words. So they really need to see some numerical data over there. And that data can be, that entire text data can be converted into vectors, which will be in the numerical format. And for this, you have libraries like TensorFlow, Keras, PyTorch, K-Train, NLP, and all. Okay. Now, coming to the next one, you also need to understand the complete roadmap of natural language processing, because natural language processing is again another field. If you see most of the companies, the startup that are coming up now, they're really working on natural language processing projects and all. Okay. So here you'll be able to see introduction to neural network, loss function optimizers, text pre-processing like GenSim, word to vec, average word to vec, solving machine learning use case, getting the understanding of artificial neural network, then again that LSTM GRU, and all those steps is again repeated over here. If you really want to specifically follow the NLP part, then this is the roadmap that you should follow. And again here, with respect to NLP, you have various libraries like Spacey, NLTK, TensorFlow, Keras, PyTorch, which will actually help you to implement all these particular things. Okay. Now, what are the combined frameworks for both machine and deep learning that you really need to be good at? One is NumPy, then you have Pandas. These all are some amazing free open source libraries. Flask, Django. Django is nothing but Django and Flask are nothing but they are web frameworks, which will actually help you to develop a lot of applications end to end. Then you have libraries like DAS. DAS is useful for parallel pre-processing. Then you have SkyPy. Matplotlib is basically used for visualization. Seaborn is also used for visualization. Then you have NVIDIA CUDA libraries. This NVIDIA CUDA libraries works very well if you have GPUs. Like in my system right now, in which I am actually sharing my screen and all, it has a GPU that was gifted by NVIDIA, and the GPU name is Titan RTX over here. And with this help of CUDA libraries, I'll be able to train bigger models in deep learning, which requires parallel processing. Then here you also have the libraries like Keras, TensorFlow, PyTorch, Cafe. Then this is the machine learning library, which is called as SKLearn. Okay. So all these things are actually present, which is pretty much amazing. And you really need to be good at all these particular frameworks. Now, if I just talk about web development frameworks, then you have Flask, Django, Web2Py, TurboGuest, CherryPy. So these all are some open source frameworks that are given where people can actually use it, try to create anything that you really want. Okay. And many people, many of you who are doing research, who are actually working in the industries, they're using this libraries extensively. Now, libraries and tools with respect to Python. As I said, that Python is an important one. So you have NumPy, Pandas, Seaborn, SkyPy, Matplotlib, Plotly, Dask. See, Plotly is a library which is used along with Python itself, where you'll be able to do some amazing use cases again. Okay. If I talk about libraries and tools with R programming language, then you have data manipulation in R. This is a library that is used, DPLYR, data visualization in R, ggplot. Then you have for data wrangling, um, then you have this dynamic report generation in R, and you also have this Shiny library. Okay. So all these things are there. Okay. Now coming to the next one. Apart from these libraries, you also really need to be good at some of the business intelligence too. That is like Tableau and Power BI, because after your model does the prediction, probably you really want to populate some data and probably create a business intelligence report. So for this kind of things, you can use this kind of business intelligence tool like Tableau, Power BI, and all. This is really very important because those reports can be shared to the stakeholders who may not have programming knowledge, but just by seeing the reports, they will be able to come to a conclusion that what should be the next decision to be taken. Suppose just imagine that if a bank wants to open a new ATM from a specific area, how they'll decide? They'll actually see the reports, they'll try to see the transaction, how much it is happening, what is the flow of transaction, how many people are actually coming over there, and based on that they'll make that specific decision. And those all reports can be actually made with the help of Tableau, Power BI, ClickSense, Dundas BI, Pentaho. So these are some of the business intelligence tools that is also being used. So these are some of the examples of Power BI reports and Tableau reports. Here you can see probably this is the sale report, this is the quarterly reports. So all here you can see amazing graphs, and these reports will be sent to the stakeholders who will then make a specific decision about what to do in the next step. Then talking about the cloud platform, guys, obviously it is Microsoft Azure, AWS, Google Cloud Platform. And in this particular platform, you will basically be doing the deployment of your application of your machine learning or deep learning models itself. Now, let me just give you a very good example, which I really wanted to showcase in the case of end-to-end projects. Okay, just let me know whether you are able to see my black screen, guys. In
Yes,
the
sir.
message, I think it will be fine. Okay. Okay.
Yes.
So if I talk about end project, okay. So let me just go ahead and talk about end-to-end project. How does an end-to-end project look like? Okay. Now suppose I have a project which is like air quality index. Okay. So what is this air quality index? It is nothing but you are basically need to forecast or predict the air quality index of various cities based on some parameters. Based on some parameters. Now, what are the parameters that you can have? You can also put your comment in the chat so that we'll try to make this interactive. Okay. So what are the parameters that you can basically use in order to predict air quality index? Air quality index basically says that how is the air quality of a specific city? Okay. And if I talk about air quality index, we obviously know, right, of cities like Delhi, right? Delhi has a high air quality index, right? Nowadays, due to pandemic, it is becoming low. If I talk about Bangalore, it may also have a air quality index high. And here you'll be able to see they from the meteorological department and all, they'll obviously make some red color air quality index or green color air quality index and all. So yes, so many people, if I talk about the first step, let's see. So as I said, from the life cycle of a data science project, what is the first step? We'll start with the data gathering, right? So this is basically my data gathering. Okay, now tell me for data gathering, what all things I need to be dependent on? Data gathering, what all things I need to be dependent on? So first of all, I need to find out which all data are important. Now in this particular case, let me talk about some of the features. So here I'll start designing my project. So I'll consider my feature one. My feature one can be rainfall. Okay, I'll just make this as rainfall. Suppose I may also say average rainfall. If we are having continuous rainfall, will the air quality index become good or not? Tell me. Yes, will it become good or not? Because all the dust particles will come down. So obviously, if we have rainfall, definitely it is going to become good. Then we can talk about humidity, right? We can talk about various gas information also, like NO2, some of the important pollution gas, pollutants, right? Which we can basically discuss about this. And these all are basically my features, right? How is the air quality index determined? If I talk about this, let me just search about it. In air quality index, how it is determined, okay? Is determined. So here I'll just talk about it because this is important. They will be using some 6 to 7 parameters, the entire air quality index. And if I search for it, let me just see. Okay, stagnant air, not able to see that particular thing, but just understand that you have a lot of features over here with respect to that. Now, where you will be able to get all this particular information? Okay, where you will be able to get all this particular information? Don't you think there will be some kind of third-party APIs which will be able to provide all this information? So obviously there will be third-party APIs which will be able to provide all this particular information. So what you do is that you continuously take this as a live stream data initially, live stream data. And in this live stream data, what you do is that you involve some people in the cloud and the big data team. Here, you also fix the frequency, like how frequently you need to take this particular, not carbon dioxide of that, sulfur dioxide, SO2, nitrogen oxide, right? Different chemicals and features we'll try to see. And here, my output feature, what will be my output feature? Here I can definitely say my output feature is basically my air quality index. It can be, I can label it from, suppose I say low as 1 to 3, moderate as 4 to 6, high as 7 to 10, and very high as above 10, right? So these are my various categories. Understand this. Okay, these are my various categories, and these are the outputs that I can have. So I have to define a model, create a model which takes these features and basically gives us this specific output. Okay, now once we take this entire live stream data, now from this particular live stream data, we will store it in some kind of database, right? Again, what is the database and all, you don't have to worry about, because this will be decided by the big data team based on the live stream data that we are getting it. Now we go with the life cycle of a data science project. Life cycle of a data science project, of a DS project. And what is the first step over here? Again, we start with feature engineering, right? I told you feature engineering, what we do some facilities like EDA, then we go and clean this data, right? We handle the missing values, right? We handle the missing values, we handle the category features, right? All these things we do. And then we go with the next step, that is feature selection, where we select only the most important feature. Then we go with the model creation. Now my model creation will be what? Whenever it takes all this particular feature, we really need to predict whether it belongs to low, high, and all. So I will be having my training and test data over here. So my data set, based on my data set, I will train my model, then perform hyperparameter tuning. Okay, I'll perform hyperparameter tuning. After I perform hyperparameter tuning, go to the next step, do the deployment in a specific cloud platform. Okay, after we do the deployment, understand one thing, guys. The accuracy of the model may come down because the data keeps on changing. Because I have been storing this particular data, because here is the process. Let's go back over here. This live stream data will be continuously taken further also, right? It will be stored. Now for the new data also, we will do the prediction. The model is already trained, and then we will also monitor it, how good it is with the accuracy level. If the accuracy is going down, then what we do? We again take all this particular data and probably do something called as retraining approach. We will basically retrain this entire model. And this particular cycle will be going again and again. Now understand how an end device can basically use it. Now just imagine this cloud is, we have, let's take this. Okay, so here is my cloud. We have deployed this particular model. This model will be exposed in the form of API. It will be exposed in the form of API, and it can be exposed to multiple client device, right? And the device can be web application. It can be mobile apps. It can be any kind of devices. This API will be exposed to them. All these particular devices, what they'll do, they'll take the new input, they'll pass it over here, and they'll get the output, and they'll display the output to the front user, right? The front user, they may also give you a notification saying that, okay, today it is going to rain. Today it is going to rain. We can also do this, right? Or it will say that today the air quality index will be high, don't go out. Is high, don't go out. Or it may also say that, okay, fine, today the AQI index looks good, you can travel a trip. You can plan a trip or travel, you can basically plan a trip. Okay, plan a trip with your family, something like this. So different kind of use cases can come into picture when we follow this entire process. At the end of the day, what outcome we are coming up, that is very much important. And this is just a way that how I have actually explained you for an air quality index. You can take up any examples, store it in the form of database, try to find out. And here also you can basically categorize this. You can also give values between 1 to 100. You can you can categorize this into different values also. So this is just one example to showcase you that how an end-to-end project looks like. But at the end of the day, what you're doing, this web application now See. Now this web application, just imagine this web application is what now? This web application becomes an AI application. This mobile app now becomes an AI application. So we have now achieved our final aim, that is creating an AI application. So don't think that data science is just about model creation. No. Data science is nowadays involving building smarter AI application. Okay, so always understand in this particular aim that the main aim is basically to create a smarter AI application, not only instead creating a model creation. Okay, so this is the final outcome that I really want to tell you regarding this entire data science process. So you should always be thinking the final goal is this. Okay, now I can take up questions. If you have any questions, you can let me know. But overall, I have explained you the entire process, how a project is basically done. Yes, so this was it from my side. I hope you like this session. I hope you are able to understand many things from this particular session itself. But yes, I will be taking up questions. If you have any questions, you can let me know.
Excuse me, sir.
Yeah.
Thank you, sir. Very nice presentation, sir.
Thank you, ma'am.
Excuse me, sir. I have a query. Sir, actually, for research to happen in this data science, is it required to improve the curve of mathematics along with the paper reading, or should we master the mathematics art now itself and go for the research? That's my doubt.
No. It is a parallel process. Okay, when the best way is that try to implement also and try to learn also. So initially, just learn the required things. Okay, then along with the implementation, try to learn more, because as we go ahead, as we go ahead and solve different domain-based problems, right? At that time, new mathematics may come, because not everybody is perfect with respect to all the domain. Tomorrow, if I'm working in some retail domain, some retail concept may come into picture, and there I really need to learn some more things. Tomorrow, I am actually working in e-commerce domain. So some e-commerce techniques or words will come. Tomorrow, if I'm working in economics domain, right? So data science is a technique that can be applied in any domain, right? Think in that particular way.
Okay, sir. And one more question, sir. What is the difference between a software developer sees machine learning and a researcher sees machine learning concept?
See, that only I'm telling you. Let me explain you two more topics. Okay. There is amazing thing, something called a citizen data scientist. Citizen data scientist. And you have something called a researcher data scientist. Okay. Now, many people ask me, Krish, after doing a bachelor degree or after doing any graduate, can we become a data scientist or not? See, you can definitely become a citizen data scientist. Okay. Citizen data scientist basically means that whatever is available right now as an open source, okay, you can use this open source techniques like libraries and solve business problems. And that is what nowadays many people are doing. They're learning data science techniques, they're using the open source library, and they're solving data science technique. But if you are planning to become a researcher in data science, then probably you really need to go with MS or PhD or your masters. You have to go through this specific part. Now the thing over here is that a citizen data scientist will only be involved in solving business problem. Okay, and researcher, they will try to create new algorithms, because in their thesis they'll have this kind of work. If I talk about companies like Google, Facebook, and all, right, they will look for this kind of role, researchers, data scientists, because they will be creating some new things. They'll be doing a whole lot of research. Whereas companies, most of the companies which are involved in solving business use cases, there they will require citizen data scientists like Panasonic and all. Now the thing is that, can a citizen data scientist become a researcher data scientist? The answer is yes, only after some experience. When you have some experience, at that time you will also be like, if I take my example, last year I also developed a new algorithm, a new pattern recognition algorithm in my company. And this was all possible because I had that years of experience itself. Right now, if I talk about software engineering,
Okay, sir.
if I talk about software engineering, what you're doing, you are basically creating a software product. Right now, what is a software product can become an AI product. How it can become? Just in this software product, bring some AI modules. That's it. When you bring some AI models, this becomes an AI product. Here also software engineering is required. Software engineers are required because they know how to create this software product. A data scientist will try to create this AI models, expose it as in the form of API, and this can basically interact with the software product.
Okay, sir. Thank you, sir. Thanks for information, sir. I'm also a subscriber, sir, for the channel. From past 6. Thank you, sir.
Good afternoon, sir. I have small, sir.
Yeah.
What is the difference between data science versus big data analytics versus machine learning, sir?
Hey, I told you, no, this particular graph which I showed you,
Data
subset
science,
of
it is
this
okay,
and
sir. Data analytics and machine learning, these are intermixing. What is the main difference between all these two?
See, first of all, let's focus on this particular plot graph that I drew, right? So this one, and here I told this is basically machine learning. This is basically deep learning. Okay. Here at least you got the information. As a data analytics, if you talk about data analytics, any work that is related to data, you can consider that as a part of data analytics itself. It's like a superset, superset. Now you may be thinking, Krish, then what is the role of ML engineer? They will be involved in ML work, definitely. Apart from that, they'll also be involved in one work which is called a DevOps. DevOps basically means how efficiently they will be deploying the models. These people will be having more cloud knowledge. Okay. Now, if I talk about DL developer, they will be specifically working on neural networks. Right? If I talk about data analyst, a data analyst will be working till the EDA part, and then they'll also be working in the business intelligence tool. Business intelligence tool like Tableau, Power BI and all. So they will be also working in this kind of tools, right? Now, data analyst cannot become a data scientist unless and until they learn data science. But data scientist can do this work also. A data scientist can do this particular work. So they are so highly paid, right? They really have to do. If you tell a data scientist to work as an ML engineer, they have to do. Sometimes you tell a data scientist to work as a deep learning developer, they have to do. If you tell a data scientist to work as an NLP engineer, they have to do. They cannot say that, no, I'm a data scientist, I'm not good at it. That is what the definition of data science comes, right? You really need to be good at everything with respect to the analytics work that you're actually doing. Does that make sense?
Thank you, sir.
Yep.
Sir, another query is there in the chart. Which is suitable creation of API, either Django or Flask?
It depends whether you are having a small application. See, I may have an application which will be having a lot of functionalities. I may have login functionalities. I may have authentication functionalities. I may have third-party authentication functionalities. If this application is small, I will go with Flask. If it is very big, then it is better that you go with Django.
Another query, sir, in chat. If we forgot one parameter during the time of data selection, how will it will be reflected in the training, during training? Shall we again retrain it?
So it is a continuous process. As I said that, if in a company you have got 95% accuracy, the company will not keep quiet. They'll tell you, try to make it 97. Then you may be doing some additional tasks where you're finding new parameters, and probably I can also use this particular parameters, and these all work are basically of a domain expert also. A domain expert will be telling that what all new parameters you can actually use.
Okay, sir. These are the queries. Okay.
Sir, what are the major difference in deep learning and machine learning, sir? For example, our brain and then robot, this major example, sir, or major difference.
Okay. So deep learning, in deep learning, you have techniques of neural networks. Okay. In machine learning, you have algorithms. Okay. In machine learning, you have algorithms. When I talk about neural networks, the architecture is entirely different. When I talk about algorithms, it's like solving some problem. Okay. Some of the architecture of neural network is simple like this. So I hope you have seen this kind of neural networks, right? It will look something like this. So this will be output layer, and based on this, you'll be getting the output here. This will be your input, right? So this is a neural network. Here, the functionalities will be a little bit different. How the functionalities will be different? Different mathematical operations will be here. Okay. Here, your main problem is that how the training is going to happen is completely different when compared to machine learning techniques. Some of the examples why deep learning can really be very much efficient when compared to machine learning. For this, one thing is that you really need to have huge data. If you have huge data, you can solve the problem with deep learning. But if you don't have huge data, I would suggest still go with machine learning. Okay. It's not like a problem in deep learning cannot be solved by machine learning. It can be, but always understand deep learning outperforms machine learning in various scenarios because of the training process, because of this hidden neurons, like what all operation will be taking. They will also be able to find a non-linear properties. Again, I'm going into mathematical thing, but just understand that this is pretty much important. If I talk about some of the application, amazing application, one thing is object detection. Okay. One thing is chatbots. Efficiently, it can be created with the help of this image recognition and all. Efficiently, if you try to implement the image recognition using machine learning and you try to create an image recognition with deep learning will definitely outperform, because the CNN that is basically used in deep learning, which is called as convolution neural network, this will be able to extract more features from the images in an amazing way. Right? And definitely this will be outperforming machine learning. Okay, so anything that is related to video, images, time series. Okay, I'll not suggest time series, but at least videos, images, audio, right? I want to classify the sound is from which category it belongs to, which animal it belongs to. So here you can extensively use CNN, which is a deep learning technique. You also have transformers, any NLP techniques. You can actually, anything that deals with text data, you can actually use transformers and solve it. Best example is question answer application, text summarization. How many of you uses InShots app? Have you heard of InShots? Have you heard of InShots? InShots app uses this text summarization technique. Their entire startup works on this text summarization. Okay, so all these things are there.
Thank you, sir. Thank you very much, sir.
Sir, I have one doubt.
Yeah.
What differentiates a small application from a large application? You told a smaller application.
More functionalities, I told, no? More functionalities. It has more and more internal microservices,
Okay, sir. So, then we have to use Django for the user interface.
Yes.
Okay, thank you.
Okay.